And so the Schrodinger model is just a little bit of an update or an upgrade maybe to the Bohr model as far as we're concerned. There are three principles or rules that you should know. And the first one you know already, but you don't have the words for it. It's called the Aufbau principle. It says electrons enter their lowest orbital possible first. So that is to say that the electrons will go into the first shell, and then when that shell is full, they'll go into the second shell, and then the third shell. But we've already done that, and I think everybody knows what we're talking about there. But now you want to remember, it's called the Aufbau principle, A-U-F-B-A-U principle. Means electrons go to that ground state first. Excuse me. The next thing is called the Pauli exclusion principle. Pauli, P-A-U-L-I, named after a famous scientist, exclusion principle. And here in parentheses I have two arrows, an up and a downward arrow right here, and that helps me remember what this is about. Now you don't know what those arrows mean just yet, but we'll talk about that in a little bit. It says that electrons in the same orbital, okay, have opposite spins. So electrons in the same orbital have opposite spins. So you have a worksheet, a big packet, which the beginning, the front page has this diagram on it. And when you look at this diagram, you see all these boxes. And each box is an orbital, represents an orbital. And so we can fill in electrons, excuse me, first here, then here, then here, fill up electrons according to the Aufbau principle. And each one of these boxes, which is called an orbital, can hold up to 2 electrons. So in the 1s orbital, you can put 2 electrons. In the 2s orbital, you can put 2 electrons. Grand total of 4. That would work for us up to beryllium, Be. But if you have a bigger atom than that, you need to start putting electrons in something called the 2p orbitals. And there are 3 2p orbitals. So it's kind of like the second shell. putting electrons in the first shell and then the second shell. So you remember the first shell can hold 2 electrons, the second shell can hold up to 8. Well, if you think about the 1s, we just said you can fit 2 electrons in this box, in this orbital. So that's like the first shell. And you can fit 8 electrons into the second shell. So the 2s has a box, and the 2p's have 1, 2, 3 boxes. So that gives us 4 boxes here. Each box, each orbital, can hold up to 2 electrons, so that gives us 2, 4, 6, 8. Up to 8 electrons in the second shell, which fits perfectly with the Bohr model. So there's one more rule, and it's called Hund's rule, H-U-N-D'(S), Hund's rule. And we always think of it as up, up, up with Hund's, hooray, up, up, up with Hund's rule. It's wonderful. This says that electrons enter orbitals of equal energy until all orbitals contain 1 electron with parallel spin. Okay? What that means is this. We have energy on this axis right here. If you look at your packet, you can see this. So if you take any set of orbitals or boxes, so for example, these right here, I'm circling the 3p. This one, this one, this one, they're parallel with one another, so they have the same amount of energy. So these are all have the same amount of energy. Similarly, these all have the same amount of energy. The 5Ds all have the same amount of energy. The 4Fs all have the same amount of energy. So when we're putting electrons in there, remember each orbital, each box can hold up to 2 electrons. So when we put the electrons in here, electrons enter orbitals of equal energy until all orbitals contain 1 electron with parallel spins. And that means that if you're up here in the, well, here's some clear territory, the 5p. I'll just pick that. If we put electrons all the way up to here, we're at the 5p. What that means is if we need to put in 6 electrons in the 5p, we put them in like this. Up, up, up. First, that's 3. And then we put them in like this. Down, down, down. And so each arrow, each up or down arrow is an electron. So we put them in with parallel spin. That means they're all, you can think of them as all spinning the same way clockwise. So if you had 3 basketballs that were all spinning next to one another, they're all going the same way. And let's say you had 2 friends and you all had a basketball spinning, they'd all be spinning the same way. So up, up, up with Hund's, put them in like this. In the 4D, you can go up, 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 up. However many electrons you need, you keep filling like this until each orbital has 1 electron, and then you go back to the first orbital, Then you put electrons down, 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 until you have as many electrons as you need. So you might say, well, that's pretty confusing. How do I know how to fill these in? Well, on the bottom of your front page of your homework, right here, there's a little tiny diagram that I'll help you with in class, but I'll show it to you here too. And this shows the order of how to put electrons in these orbitals. So you have to put them in the 1s first, so make an arrow like this. And then after this is done, you kind of think, all right, I'll go back up to here again. And then you put electrons in the 2s. And then you go back up here, and then you put them in the 2p and then the 3s. And then when you put electrons in the 3s orbital, then you put them in the 3p and then the 4s. Then after the 4s, you go up here to the 3d. Now I drew this arrow in right already, just to show you how to draw these arrows in. So 3d, 4p, 5s. Once that's full, where do you put electrons? You put them in the 4d and then the 5p and the 6s. So this is sort of taking the place of, here's a nucleus, now put electrons in the first shell, put them in the second shell, third shell, fourth shell, and keep going like that. That was the Bohr model. This is the Schrodinger model. It's a little bit more complicated. But if you can remember this, 1, 2, 3, 4, 5, 6, 7, it goes on to 7. And then you want to remember S, P, D, and F. S, P, D, F. If you can remember that, after a lot of practice anyway, you'll remember S, P, D, and F, then you'll be in good shape.